Okay, so in this lab, we're going to create an advanced load balancing with auto scaling solution. And this lab can be done either in the AWS Academy Learner Lab, or you could do it from your free tier account. And I recommend you create a free tier account. I'm already logged into the council, ready to get started. A couple things to check for before we get started. Make sure you're in the North Virginia region. Make sure you're logged in, and you should be on the council homepage when you get started so you can follow along with me. Now, what this lab entails is creating a virtual private cloud, and I'm going to show you a quick way of doing it. And we've been doing it the standard way up until now, but I'm going to show you another way to create a virtual private cloud that's much faster. But within that virtual private cloud, we're going to have two availability zones. In each availability zone, you're going to have a public and private subnet, right? So there'll be a public subnet in availability zone 1 and a public subnet in availability zone 2, and likewise a private subnet in availability zone 1 and a private subnet in availability zone 2. Now from that, we will create a launch template with an auto scaling solution that will launch 2 EC2 instances in each of the public subnets. But we're going to go above and beyond the launch template and kind of use an auto scaling solution that says, well, if a certain threshold is exceeded, create 2 additional instances. Like if traffic is heavy on those 2 instances, go ahead and create another instance in each availability zone, and you'll see how that works. We're also going to create a load balancer, and you'll see how a load balancer, again, balances traffic not only between 2 EC2 instances, but once our auto scaling solution comes into play and we create 2 additional instances, we'll actually be load balancing between 4 EC2 instances. Okay, so I'm going to pause the video and give you a chance to log in if you haven't logged in already, and then we'll go ahead and get started. Okay, so we will go ahead and get started with the lab. And so one of the first things we're going to do is we're going to go ahead and create our virtual private cloud. So in recently visited, I'm going to click on VPC. You also know you could search for it as well. If it doesn't show up in your recently visited, you key in VPC, and likewise you're taken to the same VPC dashboard. And we're going to select create VPC, and normally we've been doing VPC only, and we've been creating the subnets and the route tables and the gateways manually. There's a faster way for doing it. We're going to select VPC and more, and we're going to change the name of our VPC. We're simply going to call it Lab VPC. We're going to use the same cedar block that we've always been using for creating a VPC. Tennessee is the default. Again, we're going to create 2 availability zones, right, in the North Virginia region. So they're going to be US East 1A and US East 1B. We're going to create 2 public subnets, 1 in each availability zone, 2 private subnets, 1 in each availability zone. And we're going to click the arrow where you customize the subnet cedar blocks. And as you can see, they're using /20s. And those of you who are familiar with subnetting, okay, there's 20 bits being borrowed, leaving 12 host bits or 4,096 available IPs. And that third subnet is 4 bits are being borrowed in that third subnet, where you get subnetted addresses from 10.0.0 to 10.0.16. And then in the third octet, it keeps jumping by 16, 32, 48, 64, 80, 96, 112, right? Then you see the 128 there and then the 144. So they skipped over some subnets, but we're going to use a simpler subnetting scheme because like I've been saying, subnetting in the Amazon Council isn't as complex as an on-premises infrastructure. We have many buildings, Northwest Vista, for example, college. You got many buildings. You have And within these buildings, you got maybe 2 or 3 floors. And within each of these floors, you have classrooms and offices. So you literally have, dozens of offices and maybe hundreds of classrooms on a college campus. So your subnetting can be quite complex because there's so many subnets. Well, within a virtual private cloud, we have a VPC, and we set up only so many availability zones, maybe 3 or 4 at the most. And those availability zones could have a few subnets, but nothing that a /24 couldn't handle. So we'll go 10.1.0/24, 10.0.2.0/24, 10.3. And as you can see, the available IPs change to 256. It's actually 254. You're talking about actual available IPs. Those of you who are familiar with subnetting, you should know already that, well, the first subnet address represents the network address. We don't assign that to computers or servers on a network. And the last address in this subnet is a broadcast address that's used by all devices in that subnet to send broadcast traffic. So that 256 is really 254. Now, if you're unfamiliar with subnetting and you haven't gone through the Cisco course or Introduction to Networking course, you'll learn about it then. So no worries. But if you're a cloud computing major, this is probably as complex as the subnetting needs to be. If you just understand, and like using a /24, that each subnet is unique because the first 3 octets represent the network address, right? And they're all different. So you have 4 unique subnets. For NAT gateways, we're going to select none. And VPC endpoints, we're going to select 1, right? We're not going to create an S3 bucket in this lab. And we're going to go ahead and select create a VPC. And you could see that the subnets are being created automatically. An internet gateway is being created. It's being attached to the VPC. And device that public subnet, right, has a default route to the internet gateway. So all that's kind of created for us automatically. And it's a way of speeding things up. And if you click on View VPC, okay, and you go to your VPCs, you see the lab VPC is in there. It's available with the Cedar block. If you click on subnets, hit refresh. Okay, you see the 4 subnets that were created for us. 2 public subnets, 2 private subnets, and as you can see, they're in US East 1A and US East 1B, private, US East 1A, private subnet, and US East 1B. Okay, and you can go to your internet gateway. You have an internet gateway, and it's attached to the VPC, and you have your route tables. And if you go back to your VPCs, click on Lab VPC, right? Excuse me, click on subnets. Again, the 4 subnets are there for us. So it's a quick way of creating a VPC. So like I said, in our lab, we're going to create a load balancer to load balance traffic, and we're going to create a auto-scaling group for the web servers. So we need to create 2 security groups, one for the load balancer, because the load balancer is going to be the front end of our VPC, kind of like the lead singer, right? The front person, right? And the band members stand behind. So that load balancer is going to have a unique public IP and a DNS name. And we're going to create a security group that says all inbound HTTP and HTTPS are sent to the load balancer. And then when we create the security group for the web servers, we're going to say, we'll accept inbound port 80, which is HTTP, and port 443, which is HTTPS. We're going to accept that traffic coming from the load balancer. So when traffic comes into the internet through your VPC, it goes to the load balancer, it's checked against the security group, If it is a HTTP request, right, then that gets sent over to the web server security group, which those web servers reside. And since it's HTTP, traffic is going to be allowed. And the concept of creating a load balancer is, and you'll see when we get there, you create a target group and identify instances will be part of the target group, and you attach it to a load balancer. And then when you create an auto scaling group, you first create a launch template, right? And that's where you specify the type of instances, the hardware specifications, the security group, the web server security group that those instances will belong to. And then that launch template is attached to an auto scaling group. And then that auto scaling group is attached to the target group within the load balancer. So as new instances are added automatically, right, they become part of the load balancer target group. Because one of the things we're going to do in this lab is select health checks, where that's another benefit of the load balancer. Besides load balancing traffic between EC2 instances, it also performs health checks. So if one of those instances go down and the load balancer doesn't receive a health check from that instance after a specified period of time, it's no longer going to load balance to that instance. So that is another benefit, right? And it prevents traffic going to an instance that may be down or may be undergoing a reboot, for example. So let's go ahead and get started. We'll create our security group for the load balancer. So on the left, we'll go to security groups. We'll select create security group. And at the top, we'll give it a name. We'll call it application load balancer ALB-SG. And we'll copy and paste that in the description. And we want to select our lab VPC, right? Not the default VPC. We want to select the lab VPC, okay? And then you want to add some inbound rules that the load balancer will accept. And the two types of traffic we're going to allow are HTTP from any IP address. And then we're going to add a rule, and we're going to select HTTPS from any IP. Okay, so we add those two inbound rules. The outbound rules is load balancer will send all traffic to any IP. And you can see the rule here for the outbound rule. And then from here, we just select create security group. Now we're going to create the web server security group. So we're going to go back to security groups. And we're going to select create security group again. And we'll name this web server-SG. Now, when you give it a description, you don't have to copy and paste it. You can put a description that makes sense to you. So you could say, you know, security group for web servers, allowing only HTTP, HTTPS from the load balancer. You know, you can put a description in there if you want. And we're going to select the VPC, which is the lab VPC again. And now we're going to add our inbound rules. Now, in the past, we've been allowing HTTP traffic from any IP address, right? But in this time, we're not going to accept traffic from the internet. Remember, the load balancer is the lead singer. It's the front person. So we are going to specify we'll accept inbound HTTP requests from the load balancer security group. Just type SG, and that ALB-SG will pop up here, and just click on it. And mine ends in AB, and make sure you select the right security group. And then we're going to add another rule for HTTPS. And we are going to again select not all IPs. We'll allow all HTTP traffic coming from the load balancer security group. Okay. Outbound rules we'll leave as is. Okay. We'll send outbound traffic to any IP. And we will go ahead and select create security group. Okay. So we got our two security groups. If we click on them, you should have two security groups, Web Server SG and ALB SG. Now we're going to create the load balancer. But before you create a load balancer, you first create a target group. Okay, and to do that, we need to go to the EC2 dashboard. And so we type in EC2 and click on it. And the third one down, you see something says, we want to go to load balancing and we want to select target group. Okay, so we create our target group first, and then we'll attach the target group to the load balancer. And now you select create target group. Target type is going to be instances. Okay, so instances are going to be part of our target group. We're going to give it a name. We'll just call it Lab TG for target group. We'll allow the protocol for the target group that corresponds with the load balancer type will be port 80 HTTP. And address type we'll leave as IPv4. Make sure you select the Lab VPC. Protocol leave as HTTP1. Health checks will be on HTTP. And from there, we'll click Next. And we'll just select Create Target Group. Okay, great. So the target group is done, right? Eventually, we'll go back here when our two instances are created from the launch template, right? You could see how the load balancer will perform health checks because you should see a 2 under healthy and a 0 under unhealthy. So again, another benefit of a load balancer. Okay, now we'll scroll down to load balancers and we will click on it and we will select create load balancer. And we want to select an application load balancer for HTTPS applications. And we're going to select create and we'll give it a name. We will call this Lab ALB for application load balancer. It's internet facing. So what does internet facing mean? It basically means that, again, as I was saying, load balancer being the lead singer, it will be internet facing. It's going to have a public IP. It's going to have a DNS name, right, that we can copy and paste into our browser to access the websites that are the web servers that are behind the load balancer. Okay, and so again, access to and from the internet. It's internet facing. We are going to scroll down under network mapping and we want to select our VPC. And we have two availability zones that we created, right? So you want to click on US East 1 and you want to select the public subnet 10.0.1.0. Make sure it reads that. Click on US East 1B and go ahead and make sure it reads 10.0.2.0. Okay, both of them are the public subnet 1 and public subnet 2. Okay, now for the security group, what type of traffic will the load balancer allow? We've created a security group for the load balancer already, right? We're adding HTTP and HTTPS. So we want to delete the default security group and we want to select ALB-SG, which is our application load balancer security group. Okay, our listener will be on port 80 and we need to select the target group that we just created. So click the drop down arrow and select Lab-TG for target group. Okay, and we'll scroll down and everything looks good. And we'll select create load balancer. Okay, so we got a load balancer, right? But we have no EC2 instances yet because we haven't created a launch template and an auto scaling solution for that launch template. Okay, so the first step in creating an auto scaling solution is to create your launch template, because if additional instances are going to be added, what type of instances are you going to add? Right? Are you going to add Microsoft instances or Amazon Linux instances using T2 Micro? Right? So we have to specify that from a launch template. So we will go ahead and create a launch template. And again, we'll map the auto scaling group to the template. So when instances are launched, that they are automatically mapped to the target group in the application load balancer. And you'll see how that works. Okay, this all ties in, right? The load balancer and the auto scaling are not separate entities. They're not disconnected from one another, because a load balancer needs, auto scaling's job is to scale additional EC2 instances when needed, right? But when those EC2 instances are launched and added to your subnets, the load balancer has to know that they're there, so it can perform health checks and also load balance. So it can load balance between two instances, and then when we test our auto scaling solution, it will load balance between 4 instances. Okay, so we're going to create a launch template, and it's under here. It's underneath instances, and you'll see launch templates here on the left. Okay, we'll go ahead and click on that, and we'll select create launch template, and we'll give it a name. We'll call it lab-lt for launch template, and capitalize it. Stands out better. And we'll highlight that, copy it, and paste it into your description. Okay, and now we want to select the image, right? So we want to browse for more AMIs, and we want to select the Amazon Linux 2023. That's free tier eligible. And when that's done, you'll get some information on it. Okay, and for instance type, we'll select the T2 Micro, which is free tier eligible. And it's a good idea to create a key pair. Now, in this lab, a key pair isn't needed. We're not going to remote access into the instances at all, right? But you never know. We may have to troubleshoot, and we may have to go in there and look at the instances and see if the script that we created, for that instance generated correctly, that a web page was copied over. So it's a good idea to create a key pair. Click on create new key pair, and we'll enter a name. We'll call it lab-key pair. And we'll select PPK, and we'll create it. And as you can see, that automatically downloads it into your download folder. Okay. Now we don't have to specify the subnet. We're not going to include that in the launch template. Okay, and because that's already been identified. You'll see that when we create the auto scaling group. And then for security group, under the launch template, we want to select the security group for the web servers. So we want to select web server SG. So again, these instances will be launched, and that web server security group will be attached to it that says we're only allowing HTTP and HTTPS traffic from the load balancer. Okay. And then we want to scroll down and go to advanced details. And we want to copy our script. Okay, so I have a script here. I'll provide it in the course room. What you need to do is highlight the script that begins with bin bash. It ends with systemctl restart httpd. Okay, so that's where you end your highlight after the D in httpd. We're going to copy, and we're going to paste that script. Okay, now I'm going to go over the script real briefly. Anything with a hash is ignored. okay, by the operating system shell when it executes a script. It's used by programmers to explain what's happening, right? And so, as you can see, fetch instance ID. Instead of giving, like the websites named like Web Server 1 and Web Server 2, like we've been doing, we're specifying to automatically create a web page with the title of that instance ID. And each instance will have a unique ID. And there'll be an easy way for us to see how the load balancing works. Okay. Um, Now, this step right here, this command means to change ownership of a file, right, to the user Apache, which you as a root user to the Linux system, you're a member of, and also to the Apache group. Okay. And so you're changing ownership of this directory to Apache. The chmod means change file permissions. Okay, now we're changing file permissions to a directory so we can access it. Okay, so if you look at the first number, 755, right, treat those numbers as three separate entities, the 7, the 5, and the second 5. And then you have read, write, and execute permissions, where read permissions equal 4, write permissions equal 2, execute permissions equal 1. Okay, so the highest you can get is 7, read, write, execute. The first 7 represents what the owner has access to, or what the root user, in our case, has access to. So we have read, write, execute permissions to the HTML directory, right? That's in a subdirectory, www, that's in a parent directory, var. Okay, and so you need execute permissions for a directory so you could actually switch into that directory or change into that directory, access that directory, because without execute permissions, you can't CD into it. And if you can't CD into it, you can't read or write or anything. But so the 7, you have the execute, which is 1. You have the read permission to read the contents in that directory or read the files within that directory. So that adds up to 5. And then you have the write permissions, which add up to 7, which gives you access to edit files, edit the directory, change the name of the directory. Not that you would want to do that, but you could if you wanted to, or even delete the directory. Okay. The second 5 means members of the owner's group. Okay. Now, group members would have read and execute permissions. 4 plus 1, right, equals 5. And so what that means is they can CD into that directory, they can switch over to that directory, right? And they can read the contents within that directory and look at the files, but they don't have write permissions, right? They can't like delete files or change the name of the directory like the owner can. And then the third 5 means all other users, and they have the same level of access. So you're allowing everyone, all users on that Linux system, to be able to go into that directory and look at the contents of the file, but nothing else. Okay. Now we get to a file, the index.html. It's the same file path, but now we have an actual file, right? And notice there's no execute permissions, right? The owner has read-write permissions, 4 plus 2. You don't need execute permissions for a file. There's nothing to execute unless it's an executable script. You would not need an execute permission to a file. There's only 2 options, either you read, write, or a combination of both. So the owner can edit and look at the index.html file. Members of the owner's group can only look at the contents of the index.html file because it's only a 4. 4 is for read, not write. And then the last 4 represents all other users. So I just want to kind of explain that and not just like quickly throw a script up there, not explaining anything about it at all. Okay, so this is part of our launch template. So we're going to copy and paste the script, right? And then from here, we're just going to select Create Launch Template. So the launch template has been created. We need to do one thing. I forgot to do it. We need to go back to the subnets, the public subnets only, and enable public IP for those public subnets. So we need to go back to our VPC, because if I remember to do so, next step is to create the auto scaling group, okay, and attach the launch template to that auto scaling group. And we'll do that after we do this. We'll click on VPC. We will click on subnets, and we will select the first public subnet in US East 1A. Again, make sure it's the public and not the private. Go to the actions, select Edit Subnet Settings, and put a check mark on Enable Auto Assign IPv4 address, and click Save. Okay, now you can only do them one at a time, so take the check mark off. Select the second public subnet in US East 1B. Go to Actions, Edit Subnet Settings, and put a check mark Enable Auto Assign IPv4 address, and click Save. Okay, so now we can create the auto scaling group. So I'm going to go back to the EC2 console. And I'm going to go back to auto scaling groups. So I'm going to click on auto scaling groups. Okay, and we're going to click create. And I'm going to give it a name. I'm going to just call it lab-ASG for auto scaling group, nothing fancy. Okay, now we created a launch template, right? What does that template consist of? It's the type of instances that are going to be launched within that auto scaling group. So we're going to select Lab LT. It's the only one that we have. Okay. And then from there, we're going to scroll and we're going to click Next. So a launch template should be reading Lab LT. Again, you'll see it's an instant type, it's T2 micro. We want to make sure we select our VPC. We want those instances launched in our VPC, and we want to select the availability zones, right? So we want to click here, and we want to select the two public subnets. We want to select 10.0.1 and 10.0.2. Okay, so again, the two public subnets, they should be public 1, public 2, 1.0, and 2.0. And then we're going to click Next. And we want to attach it to an existing load balancer. And we want to select the target group that we created for that load balancer. Remember when we did the load balancer and we did the target group? So we're attaching, and I said how the two are connected, the auto scaling solution and the load balancer, right? There's a connection there. This is where the connection is made. Again, because the load balancer needs to perform health checks on any instances that are added as part of an auto scaling solution. So I'm going to select the target group, and I'm going to select Lab TG. And I want to turn on elastic load balancing health checks. And I want to select Next. Okay, for desired capacity, how many EC2 instances do we desire? We want 2. We want 1 in a public subnet 1, availability zone 1, and 1 in the other public subnet and availability zone 2. Scaling limits, right? We want a minimum of 2. So at a minimum, right, for whatever reason, we always want 2 instances available. The max that we desired is 4. Okay, and now we want to create a target tracking policy. What happens when there's too much traffic on these two EC2 instances. What we're saying is, right, we want to create two others. We want to go from 2 to 4, right, if traffic exceeds our target tracking policy. So we're going to click on that, and we're going to leave the scaling name the same. Now, on a live production network, you would probably want to leave this on CPU utilization, because you can create a auto scaling solution that says if the CPU capacity, for example, exceeds 50%, right, then, or 60%, then create an additional 2 instances. However, for the lab purposes, I can't generate enough traffic between 2 instances and they try to get the CPU utilization over 60%, right? I don't have access from all these different IP addresses over the internet, right? And making simultaneous requests to these EC2s through the application load balancer, right? So in the real world, this is probably a good metric to use, 60% average. Now that's an average CPU utilization. So what do I mean by average, right? Well, if one EC2 instance is at 60% and the other's at 40, well, if you average that out, it's 50, right? The target hasn't been met. It's a average between the 2 instances, which is okay. What we're going to do is change this to application load balancer requests count per target. So it's simply going to be based on requests. And we can generate a lot of requests. I got a command here that we'll copy and paste shortly into a Cloud Shell. And we can generate a lot of requests. So it triggers our target tracking policy and additional instances are created. We want to select our target group, which is LabTG. We want to specify a low target value, and we want a short instance warm-up. Now, for lab purposes, you wouldn't use this in a production environment, and so the target value, again, the threshold is 60% CPU utilization. I would say anywhere between 60 and 75. But in order to show you how auto scaling works, we're setting low target values and low instance warm up in terms of seconds. Okay. And from there, we'll just click next. Click next again. Click next again. We will go and look at our details. Okay, we got a desired capacity. Okay, that's the health check. That's fine. And everything looks good here. We're going to go ahead and select Create Auto Scaling Group. Now what this should do, this should generate 2 EC2 instances, okay? But the status needs to go from updating capacity. There should be nothing in here once this is complete. So you can refresh it and there it goes. It's gone away. Now we can go to our EC2 instances. But before we do that, okay? And if you went to EC2, just hit the back button on your browser. You'll be taken right back here. Go to Lab ASG, and you can verify your target tracking policy by clicking on the Automatic Scaling tab. And we want to view the target tracking policy. And it looks good. We got the target count at 5, and we got 5 seconds to warm up. Before including in the metric, okay, which will be our CloudWatch metric. Okay, so that looks good. Okay, now we can go to EC2. And we got 2 instances running, and the status check is initializing. Okay, so I'm going to pause the video and wait till we get 2 of 2 status checks passed. Okay, so it didn't take long. It took about a minute. We got 2 of 2 checks passed on both our instances, right, that were created from our auto scaling group. And what we want to do is verify that our load balancer is working directly before we actually test it. Okay, so we want to go back to load balancer. We'll click on load balancers, and it should read active. Okay, and again, 2 availability zones. And now we want to check the target group because we have 2 instances and they both should be healthy. And we'll select Lab TG, target group. And we got 2 healthy instances, right? 0 unhealthy. So again, when those instances were created, they sent a health check to the load balancer. Load balancer knows it can load balance traffic between 2 EC2 instances and 2 different availability zones. Okay, so the last step is to test it. Not the last step in the lab, but to test it. We'll go back to load balancers because we need to get the DNS name of the load balancer and click on Lab ALB. And you will see a DNS name right here. Okay, that's the DNS name. You want to click on that and copy it, right? So next step is you want to open up a browser tab. So I'll open up a new tab, right click, and go paste and hit enter. And it may take a second for it or so for it to come up. Okay, and you can see as an instance ID of F5. Okay, and sometimes, again, I get the HTTPS that the load balancer is only listening in on port 80. Hit enter. Try it again, hit enter. We hit reload here. There it goes, the second EC2OF, and it's jumping back and forth between so you got 2 of them, and you can see how the load balancer is load balancing traffic between 2 instances and 2 different availability zones. So the load balancer is working correctly. The auto scaling group was able to launch the 2 instances. That was our minimum, and that was our desired, right? So it launched 2. But now we want to generate some traffic, right? Because we got a rule, like if, like 5 requests, we wanted to create an additional 2 additional instances, right? So what we need to do is go back to the Notepad document, and this last command, right? What you want to do is replace HTTP with the actual name of the load balancer. Okay, let's try that again. It didn't copy it. So let me go back here. I'll highlight it all the way through .com. Copy. Go back into our script. And this is an outdated load balancer, right? That's not our load balancer ID. I'm going to go paste. Okay, there we go. And the HTTP part of it is missing. So we'll go HTTP : / Okay. Now we'll copy this command. And what this command does, it sends 2,500 requests, right, to look at the HTML script of the web page. So we'll copy that and we'll go back to our console here. Where is it? Here it is. And we want to probably create a duplicate tab. So create duplicate. And in the search, we'll type Cloud Shell. And you can click the window there. It's preparing the terminal. And then from here, all you got to do is right click and go paste. And go ahead and hit enter. Right? And it sends 2,500 requests. Now you could do that many times. And what we're going to do it like 5 times. We want to, the goal behind it is to create a CloudWatch alarm. So let me paste it and hit enter again. And you could see the script, right? The HTML script. It's just a simple paragraph or main heading that's centered, right? That's what the H1 means. It means it's a main heading with the name. This instance has an ID. And you can see the 2 instances, how it's load balancing between the 2 instances. Okay, I'll do it one more time. Now, hopefully what this has done is create a CloudWatch alarm. We don't want the CloudWatch log files to be okay. We want to see something in red saying an alarm's been generated. Okay, and so we'll go back to the console here and we'll type CloudWatch. And we'll click on it. See, and that's not what we wanted to see. So, we got 2 OKs here. So let me go back to the let's see if our EC2s have been generated. We'll go to EC2. Okay, I may have to look at that target tracking policy again. So we'll go to auto scaling group and we'll click on lab ASG, click on automatic scaling. And let's try it again. For some reason, I'm going to delete this. Let's delete it. Let's create a dynamic policy. We'll click on create dynamic policy. And again, we'll select application load balancer, request count per target. Target group is the lab TG. Okay, I'll change this even lower. I'll change it to 2, instance warm up to a second, and click create. And again, it's working. I just want to show you how it works. And we go back to our Cloud Shell. Let's run this command 2 more times. One more time. Okay, we'll go back to CloudWatch. See, it's still not working. Well, let's try one more time. And sometimes it takes a few minutes. Um, I'm going to pause the video for like 5 minutes, and I'm going to keep running the script and see if that does it. So I'll pause the video for 5 minutes, and I think that's what it is. It takes a few minutes for the CloudWatch to kick in sometimes. So I'm going to pause this. Okay, it worked. What I did is I ran the script 5 times, so it was like 10,000. It's 2,500, actually 12,500. I don't think I needed to do that. I think it was just a question. You got to give it time for the alarm to kick in. Once you see that the alarm goes red, you know that your auto scaling solution is working. I mean, I don't even have to go in there and check the instances. I should see 4 instances now. If I go to EC2, see, I got 4 instances running with status checks have passed. So you got 4, right? And you got 2 of them in US East 1A and 2 of them in US East 1B. So the whole infrastructure is working as intended, right? Internet traffic, goes to a load balancer. Load balancer has a security group that allows incoming HTTP and HTTPS, right, which sends traffic, load balances traffic to web servers in the 2 availability zones. Those web servers are part of a launch template auto scaling policy with a web server security group that allows only HTTP and HTTPS traffic from the load balancer. And so that was kind of like the whole purpose of the lab. And for some reason, if your CloudWatch alarm doesn't work, I wouldn't worry about it too much. It if you got two instances and you were able to load balance between 2 of them, you should be fine. And you can go to your browser and you can see how the load balancer is now load balancing between 4 instances. Just click reload and you get a 0F, you get a 1A, that's 2, a 68, that's 3, and an F5, right? That's 4. So again, 1, 2, 3, 4. Okay, so the lab works as intended. And again, you could do this either in the AWS Learner Lab, and that's what I did it in, or you can use your free tier account. And I'm going to show you how to break down the lab, right? For those of you using the free tier account, where it doesn't cost you any money, because you don't want to leave this up there and running. What we want to do, well, first of all, when you're in the Learner Lab, all you got to do is click in End Lab and hit Reset. And you can kind of do that now if you wish. For those of you using the free tier account, I'll show you how to break it down. The first thing, we want to do is we'll delete our auto scaling group. and we'll type delete. And it's deleting. And then we want to go to our launch template. It should be under EC2, so let me just go EC2. And go to launch templates. We'll delete that launch template. Delete. Okay, now we want to go to our load balancers. Is it under here? Yeah, it's over here. Let's go to target groups under load balancers. We'll delete the target group. Okay, so let's delete the load balancer first. No problem. We'll go to the load balancer. We'll delete the load balancer. And we'll confirm that. Now we'll go back to the target group. And we will delete the target group. Okay, and then finally, we can go to our EC2s. We can delete the instances. They should be deleted already. It takes a while for them to load. You can just highlight the ones that are remaining, go to instance state and select terminate delete instance. Okay. And the VPC is the last thing you need to delete. It may not delete the VPC until the instance states show up as terminated here. And you can check on that by going refresh. Okay, let's see if we can delete our VPC now. That's the last step. And you delete your VPC. Yeah, so it's got an instance hanging out there, waiting to be terminated. Show 0 running, right? But there's something in the background, right? That in the Amazon virtualized environment, that thing, even though we're not seeing it, it's still in the process of shutting down. It's probably shut down by now and terminated. So we go back to VPC. Okay, there it goes. And it's going to delete the route tables, the subnets, the gateways. You got to take care of all that, security groups. Okay, so that's done, right? And again, you could sign out. Again, I'm using the Learner Lab, but it works just as fine on the free tier account. But again, right, if you're using the Learner Lab, you simply need to go in Lab and click the reset, and it's going to delete anything that's in there. Okay, so that completes the lab. Hope you enjoyed it. Take care.